You guys want to stand up and stretch or anything like that, or you guys are good? All right, so I'll just dive in. So I'm going to talk about just building some charts using D3.js. A little bit about me. I am a front and back end web developer. I've got 12 years experience doing that. Currently a developer at Vertex Pharmaceuticals in Boston. So we build web apps, sort of internal web apps for the business. And I used to actually have a former career in scientific research as a bench scientist. And I've sort of transitioned over to web development, but still working with scientists. And there's my contact info for anyone who's interested. All right, so an overview. I'm going to build a bar chart, basically, and this is going to be sort of an exercise, code exercise to kind of show the innards of D3.js, some of which you saw with Darren's presentation. As part of it, I'm going to talk about scales and axes, and also do some transitions and interactivity. I'm going to show a layout example. So D3 has this concept of layouts, and one that's sort of everyone is familiar with is a pie chart. So I'll show an example of that. Then I'll point out some resources for people just getting into D3, and I'll take any questions after that. So I know that John went through SVG, and I just wanted to sort of reiterate some of the concepts, just to kind of get it clear, because that will sort of make the code samples make a little more sense. So scalable vector graphics are XML based. So you saw when John showed the code that those elements are XML elements. And as I said before, they're supported in newer browsers. So you have to kind of keep that in mind if you want to use D3 in sort of a more corporate environment where that might be an issue. And can be used to draw shapes, lines, paths, and even text. And I think that was something that wasn't mentioned yet. And can be styled using CSS. So here's an example of some SVG elements here. I declared some styles. So some of these elements I just kind of explicitly put in values for the attributes. And then some of them I just applied a class which will apply these styles to them. Here's a text SVG element, so you can describe text using SVG, where you put your text between the start and end tags. And then in this one, I used RGBA, which allows you to set the alpha, which is sort of the transparency of the SVG, so you can control the transparency, not just the color. And also that the order of the elements will determine sort of the stacking order when you see them. And it's also important to reiterate that there's this parent SVG element within which you have to place all of your shapes and lines and everything. So you have to first declare kind of a parent element and then your child elements. And that's true of XML and that's true of HTML too. When you write HTML, there's this concept of hierarchy. So you have parent tags, and then within those parent tags, you have child tags. And that's kind of a basic concept. So here's the output of this. And again, X goes left to right, and Y goes from top down. And here are the elements that I drew. So here's a line, here's some text, here's that transparent ellipse, and it shows it's on top of the rectangle because it came after it. And here's some clipping because part of it kind of went off the edge of where the SVG element was positioned. So this is where the edge of the SVG element. Yep.
Dynamically scale the SVG element, so if you were to click on like an example where you blow it up, and it's like, they can update, change the width of the SVG element, or would that be?
Yeah, you could do something like that. Yeah, you can using D3, you can definitely add a transition to the parent SVG element, cause it to expand and all that. But when you're talking about the relationship between your elements and your parent SVG element, what you're going to use is scales, basically. So that gives you control over where you place things. All right. So I'm going to build a chart, a bar chart, right? So given all the power that D3 gives you, building a bar chart is decidedly a very kind of unexciting type of visualization. But this talk is kind of geared towards beginners, people who don't have a lot of experience in D3, and but people who do have some experience with front-end web development, so HTML, CSS, and JavaScript. How many here have some HTML, CSS, JavaScript experience? All right, so a good number of you. So that's good. So I'm going to show a lot of code, and that's, hopefully most of you will get something out of it. But if something is way over your head, just don't hesitate to let me know. All right, so the first thing we do is we define our chart dimensions, right? So this is our parent SVG element. We define the height and the width, and then we say var chart is D3 select body. So that's the D3 selector. So it selects the body of the HTML tag. It appends an SVG element, and then it assigns an attribute of width, height, according to these variables that you assign. Now, D3 has this sort of chaining syntax, so anyone who has experience with libraries like jQuery, it allows you to kind of do a lot of things in sort of this chaining methods together, because what most methods in D3 will return the element that you either last created or last appended, right? So first it selects the body, then it appends the SVG, and then these other two methods act on the SVG, right? So we're there on that. All right, now we're going to load some data, right? So in Garen's example, he set up a JavaScript array, but D3 also has functions that allow you to consume data from external sources. So if you have a comma-separated value file, which is a CSV file, which is something that you can export from Excel. You can save an Excel file as CSV. It also has tab-separated values or JSON values if you're doing kind of RESTful web services or something like that. So you call D3 CSV. You pass in the path to your files, actually. And then you pass in an optional accessor function and then a callback function. So the callback function is required. And the callback function is what basically executes when the data is ready. So here's where you generate your visualization, is in here. And your accessor function is something that you can call on data to sort of get it ready. And what we're doing here is we're assigning for each datum that we get back key value pairs. So the key is going to be the state. So this is obviously some kind of state data. And then the value, when we add the plus to it, and that's sort of that's a JavaScript operator to coerce the value to be numeric. Because by default, when you call CSV, it brings everything in as text. So you can't really do a lot of data analysis on numbers that are read as text. And if we run this, this is the data that we get. So it's an array, and it's made up of these objects that are key value pairs. So there's a state, and then there's a value. Right? Go ahead.
So how does the CSV file work? Because I know you're using like d.state, d.down.
Okay, I'll show you. Let me show you. So date and value are the first two comma-separated values. So it recognizes those as the headings, and then everything after that gives you a date, comma, and a value. So that's the CSV. So like I said, it also has CSV and JSON methods in order to do the same thing to other types of data that in other formats. All right, so now we're going to set up a variable to calculate the width of each bar. So we're going to take the total width of the SVG and divide it by dataset.length. And dataset.length just takes our array and gives us back how many elements we have in our array. So that particular dataset had 20 elements, so we're going to divide our width by 20 elements, and it gives us the width of each bar, right? So here's where we take the data and we bind it to DOM elements. So we take our chart, which was our SVG element. Remember back here we assigned our SVG to this chart variable. And then within that chart, we select all rect elements. Now, there aren't any rect elements there yet, right? So it returns an empty selection. And this is kind of one of these weird things about D3. This is the way you bind data, where you don't know how many elements you have, but you know you need that many in your visualization. You sort of pretend that they're already there, and it returns an empty selection. Then you call this data function, and you pass in your data set. And what that does is it sort of parses and counts that data, and then when you call the enter function, it binds that data to these placeholders in the DOM. The DOM is the document object model of your HTML page. And then, and also when you call the data function, every subsequent function that you call after that iterates through all your data elements. So when you call append, it'll append a rectangle for every one of those data elements. And then you can set the attribute of x. And so you set attribute, you pass in what attribute you want to set, and then you pass in a function to this method. And it's an anonymous function, so it doesn't have a name. And it takes as an argument the data element and the index of that data element. So what the data element is, so that those key value pairs, and then the index, which is 0 through 19. So it's 20 elements, 0 index based. And it'll return I times the bar width, right? So if you think about it, it's positioning each rectangle in your chart from 0 to whatever it needs to. So at index 0, the x coordinate is 0. At index 1, the x coordinate is whatever the bar width is, and so on and so on. So we just place them side by side. For y, the function returns h minus d dot value. Okay, so d dot value accesses the actual numeric value that we want to chart, that we want to graph out. And the reason why we have to do h minus d dot value is because of the way the y coordinate goes from 0 to whatever downwards. So you're actually painting those bars not down up, but up down. So you have to sort of figure out where you start painting, and then when you give them each a height, they all kind of end up in the same place. Everyone kind of follow me on that? Okay. Then you give it the width of bar width and height related directly to the value. And then I'll fill it with blue, right? So here's our chart so far. So pretty awesome, right? Good night. We're not done yet, right? But when I open my so these are basically rectangles generated by D3, and I can open my JavaScript console in here, and if I do D3 select all, I get this array of 20, right? And when I kind of hover over them, it hovers over the bar. And when I open these and inspect them, you can see the data object right in there. And it gives you the key and the value. So you can kind of inspect and make sure. And that's kind of what binding data to your DOM is. You have these DOM elements, these SVG elements, with data bound to them, and you can use that data to sort of show how your data behaves. All right, so we need to add some spacing, right? So we declare spacing variable, and instead of width equals bar width, we'll subtract the spacing, right? And then I'll display the actual values on the chart. So what I'll do is I'll do a chart, select all text. So I'm doing the same thing I did with text as I did with the rectangle. So I'll select all text elements, call the data function, enter, and then I'll append the text, and I'll position the text at the top of each block. So I'll give it key value. Oh, well, actually, that's the actual output of the text. The positioning will be this will give me the middle of each bar. So it's I times bar width. So that's the position of the bar itself, and then I'll divide the bar width by half. So give me the middle of each bar. And y, again, I'll use h minus d value, and I'll pass in some styling elements to make it look nice. And right here, instead of multiple attribute calls, you can also just pass in all these attributes in one attribute call using a JavaScript object. That's just an alternate way of passing in multiple attribute calls. So here we go. It's a little bit better. But this chart relies on that magic number of 400, right? So what if we had data that goes higher than 400, then things get cut off. So this isn't a very flexible way to approach things. So we're going to talk about scales and axes. So scales are, what will allow you to kind of have the flexibility of throwing any kind of data into a predefined dimension. And axes, of course, are what will allow you to actually read your data, and they're related the way you set them up. So scales are functions that map from an input domain to an output range, and in Jaren's talk, he showed some scales. So the input domain is your range of possible data values, and your output range is your dimensions within which you want to output those data values. And there's all types of scales. There's ordinal scales, which are for non-quantitative values. So for our bar graph, we use ordinal values for the different states. And then there's quantitative scales. There's linear, logarithmic, square root, exponential, quantized, and there's a few other kind of more specialized scale varieties. So here's a linear scale. So a scale is a function, and how you set one up is you call D3 scale, and then you sort of configure that scale, and you assign it to a variable, which is a function that you'll later use. And you'll see this sort of pattern a few times here in my talk. So here we tell it that it's a linear scale, and we pass in a domain and a range. If you don't pass in a domain and a range, it just gives you a 1-to-1 ratio, right? So here, if I say D3 scale linear, and then I try to scale a value of 20, what do you think I'll get? Anyone? 20. So right here, I set up a scale where the domain is 0 to 100, and the range is 0 to 10. So when I scale to 20, here, what do you think I'll get? True, right? So that's sort of the gist. So it allows you to sort of, proportion down your values to fit into your range. All right. So for our chart, first we're gonna set up a variable with max value, and I'm gonna use the D3 max function, and what that does is it returns the maximum value of your data set. Now, if I had just a simple array with just numbers, you would just pass in the data set. But because we have a complex array of objects, you have to pass in an accessor function. So which of those are you going to sort? So I have to pass in function d, return d value. So the values are what I'm going to sort. So it sorts them by value, and then I set up my y scale as D3 scale linear, domain is 0 to max value, right? So that's the range of my values. There's also an extent function you can use, which will actually give you an array containing your min and your max. So if you want to actually constrain your domain to your min and max, you can do that. And then my range will be 0 to h. Right? So if I y scale 100, I get 165 using this function. All right. So for x-axis, we're going to use an ordinal scale. So for an ordinal scale, we have to pass in sort of all our states. So I'm going to set up this bar labels variable. That's basically going to be an array of all our labels, which are our states. Map. So I take the data set, and map is a JavaScript function that'll basically create another array with the results of the pass-in function called on every element of the original array. So it'll return the key, right? So the key was the state. And if I output the X scale, the domain, you see I just get an array of all my states. So the domain will be my bar labels, which is this array, and the range, for ordinal scales, we define range bands. So the range bands does kind of what the bar width calculation I did was. It basically takes your entire interval and divides it up by the number of elements in your data set. And then you can pass in a percentage for percent spacing. And then range round bands sort of rounds out the calculation to the nearest pixel so you don't get weird anti-aliasing effects in your graphic. So then we just use our scales instead of what we had before to configure our chart. So here for the x, we use x scale d key. For y, we use h minus y scale d value instead of just using the raw values. Here we use range band instead of dealing with spacing and bar width. And then here again we use y scale. And the same thing with the text. We just sort of replace what we had before and we use these scaling functions. So now we have a graph that's got all the values scaled. So it can handle the data no matter what your values are. Go ahead.
One more than like say 20 or something.
Right. So you're talking about how it cuts off the value, right? So that's where we're going to go next, right? So these values I just put on there just to kind of show how you can have a value on the screen. We're going to put axes here, and we're going to add padding to accommodate for the axes. So that's actually what I'm going to do next. So we're going to add padding around our chart to accommodate our axes. So we're going to define a chart padding variable, and then we're going to define these variables. So chart bottom is h minus chart padding. So 350 is going to give us our coordinate at the bottom of our chart. Chart right will be our width minus our chart padding. So in our case, since we have 400 by 800, that would be 350 and 750. So we adjust the scale values. So instead of 0 to h, we go from 50 to 350, right? And for our range round bands, we'll go from chart padding to chart right. So from 50 to 750 left to right. And the same thing for the height of our bars. We'll pass in we'll correct the y scale by the chart padding so it doesn't fall off the edge of our chart. All right. So now that we have the padding, we're gonna start configuring the axis. So here I define some style elements for our axis, and I'm going to use the D3 SVG axis function. And here again is where I'm setting up a function by first configuring it here. So D3 SVG axis, I pass in the y scale that I've already set up, and I'll orient it left. So that will be our y scale, or our y axis. All right, then after we've generated our chart, I'm going to set up a group element. So SVG append G creates a group element within your SVG. And a group element is basically something in the SVG spec that allows you to kind of group text and shapes and whatever together. So since axes are basically lines with text in them, it's kind of appropriate to use groups. So I set a class of axis to the group, and then I transform it. So I move it over by the length of the padding in the x-axis. So it'll be right up against the chart. And then I'll pass that y-axis, that group, into this y-axis function that I set up here. And this generates the y-axis for me. So it generates all the lines and the text and stuff. D3 just does all the work. And then for the x-axis, I do the same thing. So I set up an axis, I pass in the x scale, this time it's an ordinal scale, I'll orient it to the bottom, and I'll remove the tick marks, just because I just felt like doing that. But that's, it's just kind of an example of how you can, there are ways to sort of configure how your axis looks by tick size and good spacing and all that stuff. And again, we generate the x-axis the same way. We create a group element, and we transform it, and we have to push it to the bottom of the graph, because this orient bottom, what it does, it just orients the labels to the bottom of the axis. It doesn't actually put it to the bottom of the graph. And here I use the syntax call axis. So if you recall over here, at first I set up the group element, and then I pass that into the y-axis. This does the same thing. What it does is it passes itself into the x-axis function. So that's a way to do the same thing, but yet keep this this chaining going on. That should not be there. And then I'll select all text within that x-axis, and I'll sort of rotate it so it almost fits. So I'll set a text anchor to the end, and that's sort of the place where it'll rotate, and I'll give it a rotation of -65 degrees. So So there's our graph, right? So if you notice, the y-axis is reversed, and that's because, again, the way y goes from 0 down. So we have to fix that. And the way you do that is basically by reversing the scale, right? So before we had this h, right? So we invert the y-scale range. So instead of chart bottom to chart padding, or instead of chart padding to chart bottom, so 50 to 350, we'll actually pass in a range of 350 to 50. So that effectively sort of reverses the order of the, and I'll pass in this nice function because you see here, there's 240 and there's like little space here, so nice actually kind of sets your scale so it sort of rounds out to a nice value for your chart. And so I'll just flip all the values. So when I set up my rectangles, I'll just, instead of h minus y scale the value, now I'll just y scale the value because it sets the right orientation. And here instead of subtracting the chart padding, I'll subtract the y scale value from the chart model. And that gives us this. All right. So now we're going to go into interactions. And this is really where D3 becomes interesting. So now we set up how it looks like, but you can do that in Excel. Go ahead.
Just a question. In a static or any sort of view, is there an easy way or a nice way to export like the entire thing as a PNG or SVG or something?
Is there a way to export it?
Yeah, sort of save the whole graph that you created.
I'm sure there is, but I don't know offhand how exactly to do that. But yeah. You know? But I you know what? I'll find out and I'll put some information in the meeting.
Yeah, I did a search on that just to try to find out, and someone wrote a program. There's a link, and I can get that out to people, but it's not part of D3.
Mm-hmm.
But the person was like, hey, I want to save them, and so he wrote this program, and it's kind of ad hoc, but it worked. I think I saved some really cool D3s to SVG just like that. So I'll send that link out. I'll dig it up and get it up to group.
All right, so what we want to do is add behavior to the chart element. So after, we generate our rectangles, and then at the end we can do these on calls, and these are attaching event handlers. So I'm on mouse over and on mouse out. What I'll do is I'll select the element, and on mouse over I'll fill it with yellow, on mouse out I'll fill it with blue. Right? And these show value high values. I'll use these later to sort of show the value on hover. And so far we have this. You can do this with CSS too.